Hi everyone, welcome to another bioinformatics tutorial session. This video is a Patreon exclusive video, and so that means that only the Patreon subscribers will have access to this video and the materials. And the materials can actually be used on your own data set because I've already prepared the script and everything. So everything has been submitted for you already. So just use them and then modify them as you please. All right. So in this tutorial, I'm going to show you how to run Prokka on multiple samples or multiple files. So we are going to annotate some bacteria sequences. All right, so by the end of this tutorial, you'll be able to generate the results that is being shown right now. Okay, now what we need to do first is to install Prokka and then some additional tools. All right, so you need to make sure you have Mamba or Macomba installed, so you can use any of them to install Prokka. I will advise against using Conda itself because that one is slow. So use Mamba or Macomba to install Prokka. Those are comparatively faster when it comes to installing packages. So I'll use Mamba, by the way. So I will say Mamba create -n, and I'll say Prokka. So this command is used to create an environment. The environment's name is Prokka. Now I'm going to specify some additional information. So I'll indicate the channel. So I'll say that C bioconda C under Forge, and then I will say that C default. All right, so like this. So bioconda Forge C. I'm following the instructions that has been indicated on the Prokka GitHub page. All right, so here they use Conda, but let's use Mamba because Mamba is faster. You can also use Macomamba. So that's it. All right. So just a slight modification here. All right, so just use what I have indicated here. Okay, now we need to specify Prokka itself. What we had here is just the name of the environment. It's not the tool itself. So now we need to list the tools we are going to install. So we'll start with Prokka, and I'll also add this pandas. So Prokka will be used for the genome annotation, and then pandas will be used to generate a summary file. That's what we are going to do. So let's execute this command to install the packages. All right, Mamba has started this work, so we have to wait for everything to get done for us. Okay, the tools have been installed. So what we are going to do next is to activate the environment. So I'll use this command. So you will also see a different command if you use Conda or Macomba, but whatever be the case, the instructions for activating it will be given for you. So let's activate the environment. So I'll play the screen and I'll say Mamba like this. I'll say activate Prokka. Perfect, that has been done, so we can proceed. Okay, so now let's do this. Now let's create a working directory and then cd into it. So I'll say make that Prokka, and then I'll cd into it. Perfect. Now we are going to download the example dataset. But before we even do that, let's download all the materials. I think that will be better. So I want you to download these files. Let me just open mine for you to see. So I want you to download these files. There are 3 files. All right, so just find them attached. They are attached to this video. So just make sure to download these files. All right. So this has the links for the example data we will use. This will be used for annotating the sequences, and then this will be used to generate a summary file to aggregate the results and then place all of them in a single file for you. Okay, so let's start with this one. So this one here, let's open it. I'll just open it here. So there's genome assemblies. All right, so these are genome assemblies for Vibrio cholera isolates. All right, so the files can be found on this page. Let me just go back. So the files can be found here. All right, so on one of my GitHub repos, but you don't need to download them one by one. So all the links are here. All right, so we are going to use some Linux commands to get all the files by reading the downlink. So that's what we are going to do first. All right, so just make sure to get all the files. All right, okay, so let's just do that. So get all the files and then we can proceed. So just do that. So let's get back to the terminal and then continue. So I'll clear the screen first. And then I'll do an ls just to make sure I have the files. All right, the scripts here. All right, so we have a script. We also have this test file which has the down links of the files. Okay, now let's do this. So we are going to get the example data. So we will read this to download the files. But before we do that, let's create a directory. So let's say make the first A. All right, so let's ls to make sure the directory has been created. So we are going to use a Linux command here, a one-liner command to download the files and then place them in this directory. Right. So first of all, let's do a cut to display the links. We have them here. So we have 10 files, or let's say 10 samples. All right. Let's clear the screen. Let's do an ls again. So this is what we are going to do. We are going to do the cut again and specify the file. Then we will bring a pipe command and we say x-axis. Right. So the x-axis will help us to process all these links. All right. So we will display with the cut command. Instead of displaying, we are going to push the results, the output to x-axis, and then x-axis will link it to the command we use. So we'll say x-axis, and I'll say -i, and then I'll say -p, I'll say 4. I'll use 4 processes. And then I'll say wget, I'll bring a single quotes, bring my curly brackets, another single quotes. And I'll say -p again, and I'll say first A. So the x-axis will take the links, and then the links will be fed to the wget command here. And so we are going to use 4 processes. So that means that we are going to get 4 downloads being done at the same time. And so it's just to speed up the process. So this one is going to work, right? So now let's execute this command. Okay, so now we have done that. So what is happening is that the files are being downloaded. All right, there are 10 of them. So now they are done. They are small files, so it's going to be quick. Let's clear the screen. Let's do an ls again, and then let's ls into the first A directory. And we are going to find the files there. We have 10 first A files. Okay, so now we can proceed. Now let's do this. So it's now time to perform the genome annotation. All right, so with Prokka, you just have to specify your command. For example, Prokka, you specify that the CPUs, you specify the number, you give your kingdom, etc. So these are things you can do, all right? But then if you have multiple files like this, if you have multiple samples, then instead of just specifying, or instead of running Prokka per sample, okay, you can just write a bash script and then add some automation and then just call the bash script, specify some information, and then voila, all your genomes are going to be annotated. So that's what we are going to do. So I've already prepared a script which is here. Okay, so what I'm going to do next is to display the command that have been saved or written to the scripts. All right, so this annotate.sh script here. So I'll say cat annotate.sh to display the command. So we have them here. Now this script requires some information. All right, so you need to supply them. So let me open this script with a text editor so that I can explain a couple of things to you. So I'll do that now. So I'll open it and then I'll talk about them. So the main command for annotating the sequences is this one. Right, this is the Prokka command. But because we are going to run Prokka on multiple samples, so multiple files, I have to make the command generic so that you can change the information as you see fit. So you call Prokka, specify CPUs, kingdom, etc. All right, so basically what you need to do is to supply the script with the information here, those that have been highlighted, and then the script will take care of the rest. So we need to specify annotate that. So this is used to specify or indicate the directory which should be used to store the outputs. All right, so you don't need to create it, just specify it and then it will be created. First A that is used to specify the directory which has the first A files. We'll talk about that later. We also have extension for file extension, and we also have CPUs. Anyway, so let's get back to the terminal and then we proceed. Okay, so I'll do this. Let me just clear the screen. Oh, by the way, so before I clear the screen, I'll like to say that if you want further explanation of how the script works, I'll be happy to get it for you. So in case you run the command and then you want more information about how the script works, just let me know and then I'll give you a description of it. All right, so let's proceed. So let's do this. Let's clear the screen and then proceed. So I'll do an ls again, and then I'm going to edit the script. Okay, so that the needed information is supplied. So I'll say nano annotate.sh. You can use any text editor, that's fine, but I prefer to use nano, so take note of that. So I'll say nano annotate.sh, and then I'll specify my information. So I'll start with annotate that. That's annotate that, right? So there's a short. So annotate underscore that. All right. So I'll place it in double quotes. I'll say annotation like this. So once we specify this, the script will automatically create a directory. You don't need to create it yourself. So as you can see, when I do an ls, I don't have any directory called annotation. All right. You don't need to create it. So this command will be used to create it. I mean, that directory. So take note of that. And we also have first A that this is used to specify the directory which has the first A files. So here our first A files can be found in the first A directory here. So we need to specify that. So I'll bring my double quote, I'll say first A. We also need to specify the file extension. All right, so the file extension, let's take a look at the files. Let me just do an ls into the first A directory. All right, so for each of the files, the name that ends it is the file extension, including the dots. All right, so here we have dot first A. So dot first A becomes our file extension. All right. Sometimes you will have your first A files being written as sample name, whatever the sample name may be, dot FA, or sometimes you also have dot FNA. All right. So instead of dot first A, sometimes you will see dot FA. Sometimes you will see .fn, they are all first A files. So just make sure to specify the extension that you see. That's all that I want to see. So this one will also be in quote. So minus .first A like this. And then the CPUs, I will say 6. All right, because I'm using my normal laptop. But if you are using an HP system, chances are you have lots of cores available. So you need to increase it so that Prokka runs faster. All right. If you're using a normal laptop, then 6 should be fine. You can also check how many CPUs you have, and then you can just put the appropriate number there. Okay. So that's it. So once we supply the script with this information, then we are done. The script will take care of the rest. So we need to exit and save changes. So I'll just type Y for yes. Then I'll save it. And then I'll do this. I'll say chmod +x annotate.sh. So this is used to add execution rights to this script here. All right, that's it. So I'll do an ls again, then I'll proceed. So depending on your platform, you may see the color of the scripts change. All right, the name. Sometimes with the color will be the same, but don't worry, once you have executed the script successfully, I repeat, once you have executed this command successfully, then you are good to go. Okay, so now that's what we are going to do. We are now going to execute the script. So to execute the script, you can say / and specify the name like this, or you can also say bash and specify annotate.sh. Any of them is fine, but I'll use / this. All right. So if I want to use this approach, you need to make sure that you have executed this command here. So take note of that. So now let's execute this command. Perfect. Now Prokka has done helps for us. So we have to wait for everything to get done for us. Okay, Prokka has completed its work. So let's take a look at the output. Let's clear the screen. Let's do an ls. Let's ls into the annotation directory. Okay, so we have the output here. So each sample will have its own folder, like what we have here. So if you ls into any of them, you'll see the output. So let's ls into this one. So you can try with any other sample too as well. That's fine. So you are going to find the output here. A description of the outputs, all right, each of them can be found on the Prokka GitHub page. Let's go there. So when you are on the Prokka GitHub page, which is here, the link to this page is in the description box, by the way. So when you are here, just scroll down a bit, you'll find the output file section. So this describes the outputs, all right. So we have them here. Okay. Now, what we are going to do is to generate a summary file, all right. Now, this output, one of the things that you will do when you perform annotation is to get the statistics of the features, the predicted features. So instead of examining them one by one, what I'm going to do is to aggregate the results, all right, into a single file so that we can easily reach that and then explore and get an overview of what has been generated. So for that, I'll use this Python script to aggregate the predicted features, the counts, all right. So that's what I'm going to do. Let me first display the script first so that we know how it runs. I think I'll do that here first. Let me just do that. So I'll open it here. Let's check. This is it. So I'll open it now. All right. So I have that here. So the scripts first imports some models. Those are the ones we will use, pandas being one of them. And then we have this main DAR. So the main DAR here is used to accept an input. So when we run the script, we are going to supply it with the directory which has the annotations. All right, we already have a directory, this one here. Let me use this one here, all right. So that is what we specify on the command line. And after that, the commands will take care of the rest. And we will aggregate all the predicted features, the counts, into a single file. So this is going to be the outputs. So once we generate the output, we will open it with a spreadsheet software. All right. Now let's do this. Let's get back. So that's what we are going to do. Let's clear the screen. Let's do an ls. So what we are going to do is to call Python. Let me call it well. And then specify the Python file to this one, and then indicate the directory and annotation. So that's going to be its annotation. If you use a different directory, just specify it. So this is how it's going to be. Let's run this. Perfect. So once you do that, you are going to find the count for each of the samples. So this one, for example, number of genes, number of CDS, tRNA, RNA, tmRNA, etc. So that's for this sample. So each sample, then its counts. So it is all these counts that have been aggregated into a single file, which let's check. Let's clear the screen. Let's do an ls, and I'm going to find it here. That's this one here, the Prokka _sum.series. So you can do a cut to display it, all right. But when you do the cut and display here, it still looks very busy. So what we can do is to open the file here with a spreadsheet software, and then we can explore it further. So let's do that now. So I'll go to my file manager. So there's a file. So I'll open it now. All right. So we have opened the file. So there's a summary. So for each feature, right, the number of predicted features for each of the samples is indicated. So we have a different column for each sample. And so with this summary here, it's easy to compare the samples. It's easy to compare them with each other and to see the count for each of the feature types. All right. So this one too, if you had a reference sequence, then you can also add it and then you can compare and then see the differences. And that will let you know what genes are new, or let me just say what genes are present or absent in the sample that you have compared to the reference sequence. All right. So this summary here gives you an overview, and then you can now explore further, all right, by inspecting the individual outputs. All right. So if you have this, you can check the GFF or GenBank files and then visualize them as well. You can use tools like JBrowse. You can use tools like Artemis to visualize them. All right. So those are things you can also do. You can also use Circles to also do some visualizations. I've covered one such tutorial and I'm going to cover more. So after getting this, you take a look at the sample that you want to follow or you want to explore further, and then just perform some transcriptome analysis. Now, since it's a bacterial genome, after doing your annotation, what you can do is to perform pangenome analysis. And I've covered one side tutorial on that. I repeat, since we are dealing with a bacterial genome, then after annotation, what you can also do is to perform pangenome analysis. And I've covered one side tutorial on that. So I'll leave the link to that video in the description box. So I'll see you in the next session.